We have spent a long time explaining titrations, and we have said several times that titrations gives you a graphical picture of what mixing acids and bases are, and hopefully everyone now can calculate the pH of a titration, so can calculate the pH when you're adding as much acid, then you have base, or halfway, or a lot more base, etc. That's important. But what we're going to do now is what happens when you have more than one species. So let's try to solve this problem when we are adding these many milliliters of acids and bases. Well, as overwhelming as that may be, notice that all of these are strong. So nitric acid is a strong acid, magnesium hydroxide is a strong base, perchloric acid is a strong acid. So the overall reaction that you will have here is just the acid and hydroxide to give, well, in this case it's just water. Okay, so let's calculate how many moles of each of either hydronium, if you prefer, let's just, since we've been using hydronium all the time, it's the same, but then you create two waters. Let's calculate how many moles of that do we have, and the limiting reagent will be the one determining what's left. So if you have temp for nitric acid again is a strong acid, so if you have 10 milliliters of 0.1 molar, that means that your number of, this will be 10 to the negative 3 moles of hydronium. Okay, for, since we are in the acid, I'm going to do the perchloric acid. I have 20 milliliters, 0.4 molar, so that's 10 to the 3 milliliters, and this is 0.4. So again, the same way that we did here, just that now it's going to be 8 times 10 to the negative 3. Okay, moles. Okay, so in total, and see if that confuses you, sometimes I've seen students struggling with the exponential notation and going back to decimal. This is the same. So what I have here in total, or let's just write it here, is if I add up these numbers, it's 0.009 moles of hydronium coming from the nitric and the perchloric. How many moles of base do I have? Notice that there's a 2 here, so if I have 30 milliliters of 0.2 molar, in 30 milliliters I have 0.2, but in 1 mole of magnesium hydroxide I have 2 moles. This will give me times 4, so this should be 0.112. Let me make sure I made no mistake here. It would be 0.6. Yep, I think I did it right. I'm just trying to avoid the calculator. Alright, so at the end, since the coefficient is 1 to 1, this is going to be my limiting reagent, and what I will have left is 0.03 moles of OH. So this is going to, the result is going to be a basic solution. So let's calculate the concentration of OH negative, because all the hydroxide all the hydronium is gone. 0.0003, or 3 times 10 to the negative 4, if you will, divided by the total volume. How much is the total volume? Well, assuming that the volumes are additive, these are 60 milliliters. 60 milliliters, I'm just adding this up. This is 0.006, and I apologize, it's 0.06 liters, 0.06 liters. Okay, and this will give you the concentration of hydroxide. If you do the negative log, this will give you the POH. The pH will be 14 minus the POH, that is minus plus the log of 0.003, 0.06. Alright, so this should be lower than 7, sorry, higher than 7, because it's a basic reaction. You have some hydroxide left. The next video we will do for weak species species, which is way more harder.